All right, hello everybody. So we're still looking at number 7. I got cut off again. I think I've fixed that. Hopefully this is the final time. But we want to find sine theta and cosine theta, given that cosine of 2 theta is 3/5 and theta is going to be in quadrant 1. So basically, I look over at these identities and I like what I see. Because this one, if I know what cosine of 2 theta is, I can use that to go through and find. I'm just off to the side just a little bit now, aren't I? I can use that to go through and find sine theta. If I know what cosine of 2 theta is here, I can use that to go through and find cosine theta. So the idea is just to directly apply those identities. Okay, so let's look. Cosine of 2 theta is 1 minus 2 sine squared theta by our identity. And then since cosine of 2 theta is 3/5, I would go through and solve this guy. So subtract 1, and that would give a negative 2/5 is equal to negative 2 sine squared theta. Multiply by negative 1/2. Negative 1/2 times this guy is going to be a positive 1/5. So I get down to 1/5 equals sine squared theta. And then I take the square root. So normally, when I take the square root, right, I would take plus or minus here. But since theta is in quadrant 1, we know that sine theta is going to be a positive value, right? So this is really just the square root of 1/5. Of course, I would want to clean this up a little bit as well. So this is really square root of 1 is 1 over square root of 5. And then if I go through and rationalize that, that's going to be radical 5 over 5 is the sine of theta. So that's one value, right? So what I'm going to have you do is I want you to take this other identity. So that's the sine theta. And I want you to use this to go through and find the cosine theta, which is the other one that we wanted to find. So use cosine 2 theta. And for that one to find cosine theta, I'm going to use this guy. 2 cosine squared theta minus 1. Plug in your 3/5. And then I will leave you to go through and compute here that cosine theta is going to be 2 root 5 over 5 if you go through and calculate it there. Okay, so that's what we should have on number 7. Of course, these are our 2 answers here. All right, and then the other variation of this problem. Maybe I don't want to find sine theta and cosine theta. Maybe I want to find cosine of 2 theta and sine of 2 theta. So this one says find sine 2 theta and cosine 2 theta. Given sine theta is 2/5 and cosine theta is less than 0. Okay, so I just want to point out some things here first. I'm going to start thinking about, if I started and I wanted to find sine of 2 theta first, I'm going to talk a little bit about how that's kind of an issue if I start with that. So I know that sine of 2 theta is 2 sine theta cosine theta. Okay, so I do know one of those 2 things. I know sine theta is 2/5. However, I don't know what the cosine of theta is. I know it's negative. I don't know what its value is. So really, I only know one of these 2 things to start with. So I can't go crazy and find sine of 2 theta first. I really have to start with finding the cosine of 2 theta. And really, if I'm finding cosine of 2 theta first, my options there are also limited. I only know what the sine of theta is. So out of my 3 identities to go through and find cosine of 2 theta, which one is going to use what the sine of theta is? It's going to be this middle one, right? Because I don't know what cosine theta is, so these 2 are out. I can't use these 2. So I'm going to start with this one. So hopefully you see it's not just like a random guess. I really have to start with this one here. So I know cosine 2 theta is 1 minus 2 sine squared theta. And I know sine theta is 2/5. So cosine of 2 theta is 1 minus 2, and this is times 2/5 squared. some algebra. I've got cosine of 2 theta is 1 minus 2. 2/5 squared is 4/25. So I've got cosine of 2 theta is 1 minus 8/25. That's going to give us 17/25 cosine of 2 theta. Now, that is one answer that I wanted to find. You can see it up here. That's one of the two. Okay. I think what I'm going to do to save some room, I'm just going to box that up over here and not forget about it, but that's one of our answers. Now, back to this original problem. I still don't know what the cosine of theta is, right? What we just found was cosine of 2 theta. So I still can't quite find this. However, now I know what the cosine of 2 theta is. So now I can actually use this value to help me find cosine of theta, which I do need to find this guy, right? There's kind of like this chain of things we got to do. So now we're going to find cosine of theta using this guy, right? This bottom one. So I know that the cosine of 2 theta is 2 cosine squared theta minus 1. And I know that the cosine of 2 theta is 17/25. Is 2 cosine squared theta minus 1. Okay, so I go through that and I find cosine, keeping in mind that cosine's negative here. So I add 1, 17/25 plus 25/25. That's going to be what? 42/25. That sound right? Yeah, it looks good to me. And then multiply by a half. Should get 21/25 equals the cosine squared. And then I take the square root of that. So take the square root of this guy. I'll do that up here. And when I do that, since cosine's negative, I got a negative sign. And then this is really just negative root 21 over 5. Square root of 21 I can't do anything with, but square root of 25 is 5. So I can clean it up a little bit. It's still a little bit of a nasty result, but this is the value for cosine of theta that I would plug now in here. So to find sine of 2 theta now, sine 2 theta is 2, sine of theta is 2/5, cosine of theta was that guy up there, the negative root 21 over 5. Then I kind of multiply this out. So sine of 2 theta was negative 4. So here I'm just multiplying these. 2 times 2 is 4, times this negative is negative 4 root 21. And then my denominator is 5 times 5. I get 25. So the answer is this guy and this guy. This guy was a little bit more work to find, but I hope that's not too bad. Okay. All right. Now, kind of on to some of my favorite problems here. Okay. So we found what sine of 2x, cosine of 2x is. Maybe the natural question that's kind of burning in your mind is what's the sine of 3x? What's the sine of 4x? What's cosine of 4x? Okay. So there actually are some patterns, and there are some things we can do. We're going to just start off by how would we compute one if I were to ask, and just kind of notice what it is. So that's all we want to do with that. All right. So let's look at, say, 29. And this says express as a trig function with, it says a trig function of x, which I think I mentioned earlier. I don't necessarily like them asking a question like that. It makes it seem like this isn't already a function of x. But the argument is 4x, and they want the argument to be x for all the functions. So, all right. So what the idea is, I want to get this as a function of like sine x and cosine x. Okay, there shouldn't be anything but those. No sine of like 4x or sine of 2x or any of that stuff. Now, there's a couple different ways you can do this. And one way would be to write 4x as x plus 3x. I would not recommend it, although I could keep working with that. Just because 2x plus 2x is, I can use my identities kind of straight away. Although this would work eventually if you kept using it. But instead of doing x plus 3x is 4x, I'm going to do 2x plus 2x. Okay, and then we got to use our sum identity. Okay, so this is sine 2x cosine 2x plus cosine 2x sine 2x. And what I'm about to write hopefully is not too surprising, but I wanted you to see it this way just in case you didn't see it the other way. It's 2 sine 2x cosine 2x. Now, let me write off to the side how I could have guessed that already, okay? And it's a little bit odd, so if you're okay with this, and we're not done with this over here on the left, but let me just kind of make a note over here that another way to think about this is to say that, okay, sine 4x is like sine of 2 times like 2x. If I can write that, and I hope you can see that in nice red. Okay, if you can, it's 2 times 2x. Well, if I compare that up to here, this is like my input is like an x here. So sine of 2x is 2 sine x cosine x. So what's sine of 2 times 2x? Here I'm like putting a 2x in for this guy. So this is really 2 sine 2x cosine 2x. I'm really just using this identity, but instead of the x, like there before I did like a value of like 22.5, plug that in. Here it's like really like plugging in a 2x. It's really the exact same reasoning, but people may not like it as much. In the past I've kind of seen that, but point being, I could think about it this way and get it, or I could use that sum identity for sine. Either way, I get down to this point. And I'm still not done because I want it in terms of sine x and cosine x entirely. So what I would do at that point, I'll give myself a little bit more room. Sine of 2x, I have an identity for that, so I'm going to plug that in. I know sine of 2x is 2 sine x cosine x. And I know cosine of 2x is... Now here, there's a couple different options, and it really doesn't matter which one of the three I use. I would probably just stick with the one with sine. I would say would be the cleanest since I started with the sine. They're going to take answers with sine and cosine in them, so it doesn't really matter. But I'll just use this guy, 1 minus 2 sine squared x. And then what I really have then is a 4 sine x cosine x if I multiply those. And then distribute, so that's a 1. Actually, let me write it down like this. And then I just distribute. So this is really just 4 sine x cosine x, right? And then times this guy. So I've got minus 8 sine x times sine squared is sine cubed x and cosine x. So that's one way to write this. Alrighty. All right, so let's look at number 30 here. So let's look at another one. Say 30 is cosine of 3x. So this one I'm dealing with a 3 instead of a 2. I'll just do cosine of, say, x plus 2x. So here I am just going to use the sum identity for cosine. So it's going to be cosine of x, cosine of 2x, and then I got a minus sine x times the sine of 2x. Right. Cosine of 2x, I'm going to plug in the version involving just cosine. So I'm going to have cosine x and then times 2 cosine squared x minus 1, and then this is minus sine x times 2 sine x cosine x, plugging that identity in here. Okay, then some algebra. Distribute this. I got 2 cosine cubed x minus cosine x, and then I got sine x times negative 2 sine x. That's negative 2 sine squared x cosine x. Okay, I have no common factors there. I mean, I could manipulate that a little bit if I wanted to. But for me, this is fine if I leave it like this. What I'm saying is, like with the sine squared, I could have put a 1 minus cosine squared in there and then continue simplifying. For me, personally, it's okay. There's different ways to write these answers. This is the main idea, though. It's I want to use some kind of double angle identity, or I want to use some kind of sum identity, simplify it, and that's all we're after, really. Okay. Now, once I get to this answer, I mean, I could simplify this, but I've already got it in terms of cosine x and sine x. No more double angles or triple angles or anything like that. So that's it. Okay. All right. So just a couple identities. All right. So we're going to look at, say, verify this guy. So 37. So this is sine x plus cosine x. I think it's quantity squared equals sine 2x plus 1. All right. So typically, and this has got parentheses there. So I start with the left-hand side because I can FOIL that out. So let's see what this is going to be. So I've got sine x plus cosine x squared. That's sine x plus cosine x times sine x plus cosine x. And we got to distribute all of that out. So I got sine squared plus sine cosine plus sine cosine plus cosine squared. Okay, there we go. So you might notice that last part, the sine squared and the cosine squared make a 1. So I really just have 1 plus 2 sine x cosine x. I add those like terms. And then, of course, this guy right here, the 2 sine x cosine x is sine of 2x. So I just have 1 plus sine 2x, which you could also write that as 1 plus sine 2x. That's not a big deal. Just commutative property of addition. So I got a QED. In some ways, that is really not too bad as long as we remember the double angle identity. Okay, no, one more identity. So this one I've got, this is 44. One plus cosine of 2x divided by the sine of 2x is equal to cotangent x. Okay, so I can pick either the left or the right. Of course, here I think I'll do the left because I've got a couple different double angle identities I can work with here. So let's pick the left. 1 plus cosine 2x over sine of 2x And then we'll write this guy out. Okay. So this is sine 2x is 2 sine x cosine x. Now, you may want to think about a little bit about what's going to happen here. All right. You really need this to be cosine over sine. So in order for that to happen, there's probably going to be some kind of cosine squared term. In particular, like a 2 cosine squared would be perfect, right? And if it was 2 cosine squared, one of the cosines would cancel, and I'd get cosine over sine, give me cotangent. So just kind of thinking ahead a little bit, I can see that probably the substitution I'm going to want to make is getting this entirely in terms of cosine squared here. Because if I do the sine squared, it's not going to be helpful in getting this guy. At least initially, it would just be making a little more work for myself. So the substitution I should use here is this, sorry, I pointed at the wrong one, getting it entirely in terms of cosine squared. Use that cosine 2x as 2 cosine squared minus 1. So this guy, 2 cosine squared x minus 1 is cosine of 2x. Plug that in. And then notice that 1 minus 1, that's just 2 cosine squared x over 2 sine x cosine x. And then all our wildest dreams come true with the 2's canceling one of the cosines. So I get cosine x over sine x, which is going to be cotangent x. And that's going to give us our QED. Oh, QED. Okay, so hopefully you like the double angle identities. There's some other ones that are like product to sum to difference, half angle identities. I'm not going to do those. Very rarely. In fact, the story goes, you can probably end the video right now, but if you want a boring story, so that the only time I ever used the product to sum identities was in a partial differential equations class in grad school, and it was on a test, and I didn't remember what it was, but I remember that I could get it if I added the double angle identities together. So I ended up kind of completely didn't know what it was, but I derived it for the test. So if it does happen, you can get there with what we already know. Okay, if any of the other ones, they're just kind of extensions on what we've done already. But hopefully you enjoy that, and then we're going to start chapter 6. Going to talk about trig equations, and that's going to be a lot of fun.